Hello everyone, today we are looking at another Leetcode problem. This is 330, find the original typed string number 1. So in this problem, we are given a word which is typed by Alice. Now what the problem says is that Alex at times can have a long press of characters by mistake. So let's say if she wanted to type X, because of the long press, she ends up typing X multiple times. Now, this could have been intentional, writing X 4 times, or this could have been the result of a wrong long press. And this long press mistake happens at max 1 time, which means either it was intentionally written 4 times or this was a mistake that happened, but it happens just once, which means that if I have another repeating character, then there is a possibility that this whole string is what Alex intended to write, or X is where the long press created the problem, or Y is where the long press created a problem. And so, what we have to do is return the total number of possible original strings that Alex might have intended to type, which means we have to eradicate the mistakes and look at all of the variations that are possible and see what was the total count of possible total count of original strings. Okay, so let's understand this problem with an example that they have given. Okay, this is the example. Now first thing is this mistake can happen at most 1 time. So one of the variation that Alice might have intended is to write this original string as it is, which means the mistake here is equal to 0. Now we need to count all the variations where mistake is equal to 1. And the way we are going to simulate that is by looking at the previous index. So let's say this index is I, and so the previous one is I minus 1. And so if I happen to be the same as I minus 1, which means this double character that I'm seeing is probably a mistake. So you can stop this here and count this as one variation. Okay, so let's do that. So 0, 1, 2, 3, 4, 6. Okay, so we start our I pointer starting from 1 because we need one character to look back. So let's see what happens. At I equal to 1, so this is where my I is and this is I minus 1, we have B and A. Now B is not the same as A, so a repeat has not happened. All good. A and B are good to proceed. Okay. Next, we come to the B. Okay. Yeah. Now this time, when we look back, we see we have already seen B. So there is a chance that this is a repeat. Okay. So one of the variation that I am creating here is, so we can count this as one variation. Another variation is just stop at this B. So we get 4C. This is another variation. Now let's continue further and see what happens next. Next, we move further and we get to C. Now when I look back with C, it's different, so nothing happens. Let's proceed further. This time, I have C again. So when I look back, I've already seen C once, I'm seeing it again. So maybe this is a mistake. So the variation that I get here is this. This is another one. Alright, let's move further. This is 4, 5, C. Okay, I've already seen a C here. So maybe this one is a mistake. Okay, so you stop here and take this much. So we get A double B double C. This is another variation. And we proceed one more time, the last time. And so here we have seen double C already here. And when I look back, I see that this is the same. So maybe this is a mistake. So let's keep this as it is. So I get double B triple C. Okay, and this should be 1 because it is one variation, and this is another one variation. Now let us count all the variations that we have seen. Okay, so 1, 2, 3, 4, 5. So these are the 5 variations we have seen, and that's the answer. So let's look at the pseudocode for this. Def possible string count. For this, I get word as an input, which is a string, and then I say, let me take n as the length of this word, and let me take answer by default as 1, which is the count for the original string, which is to say that mistake is equal to 0, because we have at max 1, right? Now, let's start counting for the mistakes. So, for I in range starting from 1 till n, starting from 1, so I can look back. Let's see, if word of I minus 1 is the same as word of I, then I can say answer plus equal to 1, which means I am seeing a duplicate at this point, which means stopping at this point gives me one variation. So that's what we're counting. And then finally, we can return answer. And now the time complexity of this is quite straightforward. It's just order of n. Now here the problem said that we can have at most one mistake. So if there were like multiple repeating groups, we are saying you just count all of this, or all of this, or all of this, and so you're ending up doing addition. But what if you could do multiple mistakes? Okay, if you could do multiple mistakes, then there is a chance that there is a mistake here, and there is a chance that there is a mistake here, and there's a chance that there's mistake here. So in that case, you would have to do the multiplication instead of the addition. I hope this made sense. That's about it for this problem. I'll see you again with the next one. Thank you. Bye bye.